All right, so let's continue our lesson 3.5 discussion on symmetry with this next question. All right, so it says, what type of symmetry does this figure have? All right, so this is a flower. It's a 5-petal flower. It looks pretty nice. So we are going to think of this like a regular pentagon, right? A 5-sided figure is a regular, if I could spell regular, right? Regular pentagon. Here we go. There we go. Now we're cooking. Again, because it has 5 leaves. And because it looks pretty regular, it's going to have a lot of nice symmetry. Okay, so let's start with the lines of symmetry. So here, we can start with this petal here, the tip, and we can go straight down. So it's like we're connecting the tip of a petal to the in-between connection of 2 petals. This would be one line of symmetry. We could do it the next petal. That'd be our second line. We could do it the next petal. It's kind of bad, sorry. It should go more through the center. There we go, that's better. That'd be our third line of symmetry. It could go from this petal up. That'd be our fourth line of symmetry, and we go this petal down through. And that's our fifth line of symmetry. So this is going to have 5 lines of symmetry. And again, as we talked about with the regular hexagon, typically they have as many lines of symmetry as they do vertices. So 5 lines of symmetry. And now the rotational symmetry, again, because this is a regular 5-sided figure, a regular 5-leaf figure, we're going to take 360 divided by 5. And that is 72 degrees. So we're thinking that our rotational symmetry is every 72 degrees. So if I go, I'm starting at the petal with 1. Let me do it in blue. Okay, so this is going to be in blue. So if I go this way 72 degrees, there we go. I rotate this petal on that one and so forth. If I go that one, another 72 degrees, that's 144 degrees, right? Then I go another 72 degrees to this petal. That would be 216 degrees. Then I go another 72 degrees to this petal. That would be 288 degrees. And then finally, if I go all the way around, add one more 72, I get to 360. But again, 360 doesn't count. That's your stopping point. So the rotational symmetries are 72 degrees, 144 degrees, 216 degrees, and 288 degrees, about the center of this figure, right? About the middle point right there. Okay, so again, regular figures have a lot of nice symmetry. All right, next one here. What type of symmetry does this figure have? So this is a rectangle. Now the issue here is that you have this pattern on the inside. If this was just a rectangle, this object would have some lines of symmetry. They would be this way, and they'd be this way. But because of these dots here, right, if you reflected it down, this dot would go here, which would not be on top of that dot, and vice versa. And if you go left to right across this line of reflection, the dot would go here, not on top of it. So there are no lines of symmetry. And again, it's all because of the design inside of this rectangle. But I believe it will have some rotational symmetries, because I believe that this dot, if you take it and rotate it 180 degrees, it'll come to this corner. And if you go another 180 degrees, you'll come back to the beginning, so you're done. That's 360, and you're done. So this only has one rotational symmetry of 180 degrees. Okay. All right, last but not least here, our final slide. It says a company CEO wants a new logo that looks the same for each rotation of 30 degrees and uses the 3 companies' colors. What are some possible logo designs? Well, I'm going to do one for you guys. So if we want to go every 30 degrees, then we're going to take 360 and divide it by 30. This will give me how many vertices I should have. Well, 360 divided by 30 is 12. We need to have 12 vertices or 12 sides in our figure. This is what we call a regular dodecagon. Regular, that's my design. a regular dodecagon. Decagon means 10. When you put the do in front of it, that means 12. Regular dodecagon. So I'm going to draw this as best I can. So I'm going to try to do like, I got to do 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's terrible. Let's try one more time. I'm sorry. So let's do 6 on each side, right? Let's do 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. That's the best I can do. All right. Okay. And let's make wedges, right? So let's put a center and let's just connect them. So 1 wedge, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And again, pretend this is a regular dodecagon. Again, I'm just trying my best here. And you know, say their emblems are red, white, and green, right? So we could do like a blue circle. How about that? We could do a blue circle, right? And then how about we do like the outsides, like blue, blue. I'm sorry. Let's do green. So green and 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 green, right? If you wanted to color in some, you could, but there you go. That makes it safe so that if I take any vertex and rotate it every 30 degrees, it would line up on the next vertex. Okay? So it looks like my company is an eye care company, right? Looks like an eye there. Okay? Sure. Fun times. Look at that. A little creativeness in mathematics. Never hurt nobody. All right. Hope you enjoyed this video. We'll see you in class for the practice.